let's start with mount head. This is going to be the final version of what we are going to do.
Yeah.
Okay, so what is mount head? Mount head is a really nice geological region in Canada. It has several anticlines and synclines, and they are overturned. So this is our interpretation of mount head. We used the structural data available from public sources, and we also used we use the map, we use structural data, etc., and interpolations from Geomodelr. So this is the region we are going to be modeling today, right? Okay, so let's start by the beginning. Let's start by creating a geological model. So all of you have an account and can create a geological model. So let's call this Mount Head Canada 2. Okay, we're going to write a short description about our model. Okay, this is a short description. We can, of course, create public and private geological studies. For private geological studies, you need to have a paid plan. But if you want, we can. If you want a demo with private data, you can contact me, and we can arrange that. Of course, okay. So let's make this geological model public, and let's go here to view it. Okay. So the first thing we notice is the screen with the different with our study. So it has the different parts of our study: the files repository, the 3D model, which is in georeferenced right now, the model versions, the articles, and the permissions. Okay, so the first thing we will do is that we will upload files from our desktop. So we have this file, which is geology, and let's see what it contains. It contains shape files with all the information that we need for them. So we have the faults, and the geology. We're going to use all that information. Before uploading it, we have to make a zip file of it. So we zipped it, and let's upload it. So yeah, so it contains faults, which are line strings in shapefiles. It contains units, which are polygons in shapefiles, and it also contains faults, which are faults which are not recognized by Geomodelr, but we can use them as a layer to interpret them. Okay. It will take a few seconds to upload. Let's upload also this file, which is the structural coordinates. So this is the dips. The dips. So it has a dips file has several fields. For a field which is an ID, you can use any of these two. The azimuth or the strike, and the dip. So it also has the x location of the point, the y location of the point, and the height of the point. In this case, these are superficial dips, so we are using them with the height, with the topography. Okay, so let's upload also this file and let's submit. Good. So to georeference the model, we will need a digital elevation model, which is going to, or a topography, which is going to bound our model up. Yeah. So we can use them files, but right now we are going to use one that is going to be generated automatically by Geomodelr. Then we need a map. We can create an empty map and it will be void. But here we will use GIS files and we will use the geology for the geological units. We can use map unit for the unit, and we can also upload as many other units that we want or that are important. That are important for us. So yeah, we are going also to load faults. We're going to upload faults. We can name them so that name is important in Geomodelr, and we can choose then feature, attitude, confidence, generation, max age, in age, movement, symbol. Okay, did I pick it correctly? Yeah, false. And we're going to go next. So as we used files, we can view how they are, where they are located. As we use faults and a geological map, this is the region that we are going to model. You can see the geological region here. Even it looks really nice. A really nice place to do geology, right? Okay. So yeah, this is the region that we're going to model. But we have a problem here, and is that Geomodelr does not work well with coordinate systems which are not in which are geographical, like in degrees. And this is a geographical coordinate system, so we have to pick a coordinate system that works well. So we look for Canada, UTM, and more or less that region is works well with this coordinate system with NAD 83. Which is NAD 83 11 of the many Canadian coordinate systems. This is one that works well for this region. Let's check close. Let's select the region. Okay, and that should work, right? So let's create. We have the coordinate system. We have the bounding box, and let's go to create model. Okay, so it'll take a few seconds to create our geological model. To create our geological model. When it's done, we're going to be able to to see our geological map. We're going to be able to see our topography, etc. Let's see, for example, the visualizations page. This is our map with the topography. It looks cool, but the colors aren't quite right. So they are assigned randomly. So we're going to go to polygon operations, geological unit, and we are going to click on add or change unit. So we have all our geological units here. Let's click, for example, a unit, and it will show us the BAM formation. We can select its age from the stratigraphic chart. This is a Devonian rock, so a Devonian geological unit. So let's pick this, and it selects the color, and when we click submit, you can see that the band formation has changed its color, and it's also reflected here. So we can take up the nodes so that it looks better. Yeah, it would be this formation. Okay, so this is a little bit tedious, so we're going to show you a really nice feature of Geomodelr, which is being able to save and load model versions. So let's go back to our study. And let's go back to the studies page. We can go by clicking there in my studies, or by clicking here. Yeah. So let's go to Mount Head, Canada, which we already created it, which was the one that we showed to you. And let's delete this model. Oh no. Yeah, let's delete it. Yeah. So we have here model versions. At the end, creating a model version is just giving it a name and submit, and we can load them for every stage of the geological model. So we already have a stage where we gave the geological model the topography and colors. So I'm going to set that version of the model. Okay. Yes, this looks like geological colors. So here we only have the map, which has its poles, which we can click and see the formation, the unit, the feature, genesis, etc. You can click on it to see what it has. Okay, so let's go back. Let's go back. Okay, and let's go to the geological map. Okay, so okay, so this has already loaded the files that we just uploaded, and also has these divs. These are the divs. Okay, so let's use them to view our map. Okay, so let's create a new dataset. The name of the dataset is called divs. Create the divs dataset. Let's select this. Let's select all this. So we need an X, a Y, and a C. We need deep, which is automatically arranged, and we need a strike, which here it's called azimuth, and an ID for the strikes. And let's click submit. Okay, so we created a deep dataset that contains 42 deeps with a strike and deep. We can then go here, click options, click vector layer, and click add more layers. Add more layers from dataset projection, deeps. Let's name it deeps. And let's name it, and let's click submit. So now it loads the deeps. Let's hide the nodes for now to see our geological map with the directions it has, so we can analyze better how we are going to model it. Okay, so deeps work with that direction, with a strike and deep, and in the map they are shown like, well, map deeps, but in cross sections we will see them slightly different. So let's go back to Mount's Head study page, and let's check how we can create our first cross section. Okay, we're going to name this cross section AA. We're going to add a new cross section. Let's wait a few seconds for the map. Let's create this cross section. Well, let's see where the deeps are, so that we can pick better which direction the cross section, which okay. So this cross section is special because it's the first cross section of the interpolation. As the first cross section of the interpolation, it gets to define the direction in which we have to create cross sections for them to be part of the interpolation. So let's get the lowest coordinates. Okay, which is the bottom of the cross section, and let's click submit. Okay, so this is our first empty cross section. This is a new feature we developed last days, which shows us all the contacts of the cross section with the map directly without having to look at the point. Well, you can look at here, but here they are loaded directly, so that you don't have to look at that. So let's make a few operations. So with the first cross section, you have a geological model, and it can be hard to grasp that just by doing a single cross section you have a geological model, but it is. So the first cross section of your geological model not only defines which direction the other cross sections need to be, but defines an interpolations, that is a smooth transition between cross sections. Of course, right now the interpolation is just copying the cross section. So let's first add the dips, to interpret our cross section better with the given directions, and let's click submit. So we just named the dips, and we also said, okay, we are interested in the dips that are at 1000 meters around my cross section. We can add as many data sets of deep projections as we want. If we have dips really close and we want to distinguish them from dips that are farther away, we can do that. So we see here the dips for our cross section. This dip seems like outside the mountains because probably they are too far away and the mountains are really sharp. So to edit cross section, use simple operations, simple polygon and line operations. You can just use divide and join. The divide operation is very simple. You pick a node and the operation has to end at another given node. So when you go from a node to another, then you separate a polygon into pieces, and then that creates a new unit. And the join is the opposite operation. You take one polygon, you click another which is next to it, and then it joins them. Okay.
Hello.
Okay, I'm going to mute.
Hello.
Okay. Okay, let's continue. You can add lines. You can add also faults with line operations. Faults are faults also have very simple operations to create them. You just click one node or click in the area and click as many points as you wish. When you want to finish the fault, you click the last node again, and that's it. Extend also has other operations like extend, separate, remove, etc., which can be useful to create to edit defaults. Okay, so and the last kind of operations are node operations. So we see that the nodes are really important for us to edit our geological models. So node operations help us to add nodes to a polygon so that we can divide them there or use them. They help us. We also can remove nodes. We also can join two nodes, one from a fault and one from a polygon, etc., etc. You can view the documentations for all the operations here. It has the documentation and a short video of what you are supposed to do. We can see that for pretty much everything, for polygons, for faults, etc. Okay, so as we have short time in our webinar, we're going to load this cross section finished from our model version. So let's again delete our model. Let's click version 2 and let's click shift version as model. It will take a few seconds, of course, but let's wait. So far, what do you think of Geomodelr? Okay, you're finished. I'm sorry, Alvaro. I just muted you because you need to mute you. Okay. Okay. So let's continue. Okay. So we have the second version. This version has a single cross section which is already edited. Okay. And we also have the visualizations page, which will allow us to see the cross sections visualization. So let's see this. Okay, so from the first cross section, you have a geological model, of course, and that geological model, you can use to do pretty much everything. So let's for example create a wireframe of our faults. So we name it faults, we name it triangulated faults, and we click submit. Okay, so here we have 3 interpolated faults, which are just uh, uh, an interpolation, an extrapolation of the faults that we see in the cross sections. But to be interpolated or extrapolated in this case, we need that those faults are named. So we have fault 1, fault 2, and fault 3. If we go here, we see that line operations has an operation called name, and it's important to have the name, which is case sensitive, correctly done, and that also only one fault is named like that in a single cross section, so they can be interpolated. Okay, so let's go to create another cross section. So as I said, right now we have an interpolated model, a model that can be interpolated anywhere. This is just too simple. This model is just too simple right now. Okay, so let's say that we create a cross section called BB. We call interpolated cross section, and let's create it here, for example, at minus 500, and let's say take to interpolate geology. Okay. Okay, so we have created this cross section from AA, which is pretty much a copy of the other, and actually the contacts are not the same. We have to make a small editing process to have those contacts right. So, but every time you create a new cross section, it will be easier and easier to create your new cross section, because most of it will be already done. Yeah, for example here this geological unit is part of site, but this geological unit is not. We can do this to divide this unit and join. The join operation is quite easy, so it's going to be really easy to take join operation is quite easy, so it's going to be really easy to join two geological units into one and then divide them and then do our work. We can also start from scratch in a new cross section if on a new cross section, but we will get to see that there is going to be a point where cross sections are just like very similar to what we need. Okay, so yeah, the first cross section might take a while, but we will. But the next cross sections will be much more easier to make. So let's jump here to the third version of our model. Okay, so to see what I mean, let's set this version as model. Okay. Okay, so we have these three cross sections. We see that they are far ahead. Okay, let's see them in 3D. They are far from each other. I'm sorry. Let's see them in 3D. So here you see these three cross sections interpreted also from structural data, etc. And what we are going to do is that we are going to create a new cross section called CC, and this cross section will be between A and E. Oops. It's also created at -500. And we have to give them a -500, and let's click submit. So what Geomodelr creates is a smooth transition. Between the cross sections. This smooth transition, we can see it. We can see it here. We can see, for example, that if we create a cross section, let's delete this for once. You can see, for example, that if we create a cross section called cross, and it's going to be called, and it's going to go from here to here, or better, from here, from here to here, -500, and we say interpolate the geology, we click submit. Okay, yeah, let's see this. So we can see how Geomodelr creates a smooth transition between these two cross sections, which respects all the boundaries and which is as smooth as it can. Of course, at some point, it's the transition is way better when the geological model has more cross sections. So, but as you create cross sections, it becomes easier and easier to make more because most of the cross section, or at least the deepest parts, are good to go. So, for example, then let's jump to our last uh, saved version of a model. It has several more cross sections. Well, not several more. Like it has 7 cross sections. Let's go, for example, at the visualization page. Okay, so here we see a huge set of cross sections, and let's create, for example, a false visualization of them. Will take a few seconds to process, but when it processes, we can see how the faults behave. We can use a combined visualization to view those two visualizations in one. Okay, you can see the faults where they are passing with in the geological model. And let's finally make a block model. So the block model will use the interpolation. You can freely draw any polygon we want. Let's draw a star. Let's draw a star, and we can set any distance, any top we want. We need to say which is the bottom plane coordinate, and the top plane coordinate. In case in the study you have which are like the coordinate ranges. In case you set top coordinate above the topography, it will take the topography. So let's click then submit, and let's see our star.
Pilar, con Álvaro Montoya.
Let's check how our star is shaping. Yeah, so this is our star. Let's also create a combined visualization with our cross sections plus the block model. Let's click submit, and yeah, and this is our star with all the context being perfectly respected and with a smooth transition being generated between the cross sections, even when they are really really strange in their behavior. So great. This is Geomodelr. Okay, so finally, to finish this tutorial, well, to this webinar, let's check the model versions. So let's create a new cross section called BB. Oops. Let's create it just in the middle. Minus 500. Click to create okay, interpolate, and let's submit. Okay, now after submitting, we have a cross section which is an interpolation of the two cross section we made. We still have to correct the position of the faults and to correct a bit the position of the contacts, but it's in a huge percent really done. This model after that we can save a model version like the ones we have been using. So let's call this version 5. Submit. Version 5, we can download version 5 to our computer. We can use this version 5 with Python. With Python, we actually can go here to tutorials to see how to use our model and share it, and here you can see the documentation of Geomodelr query tool. With Geomodelr query tool, you can use the Python client, which is open source, to create programs that will query your model to make to make anything you want. Next webinar, we will be using heavily Geomodelr query tool. We are going to calculate resources in Geomodelr with using some free open source geostatistical packages and our Geomodelr query tool heavily. Okay. If you don't know Python, there are ways to use Geomodelr query tool from the command line. You can see all the information you need here in the documentation, the Geomodelr package, etc. Okay, so so thank you for coming to our webinar.